Now let us deal with this example. So find the roots of the polynomial equation x to the fourth plus 7x cubed plus 8x squared minus 28x minus 48 equals 0. So firstly, we need to identify the possible roots. So we can get that by dividing the constant term by the coefficient of the leading term. So since the coefficient of the leading term is 1, it means that we will just get the factors of negative 48, and that would be the possible roots for this equation. So we have here positive negative 1, positive negative 2, positive negative 3, positive negative 4, positive negative 6, positive negative 8, positive negative 12, positive negative 16, positive negative 24, and positive negative 48. So that's it. Let's check. 1 times 48, 2 times 24, 3 times 16, 4 times 12, 6 times 8. So we're good with that. And then, next, we are going to apply the factor theorem. Remember the factor theorem? We can make use of the remainder theorem or the synthetic division. And we need to obtain here a remainder that is 0 to say that the given root is a factor of the given polynomial. So, first, we need to check or make a test for 1, for the possible root 1. And then we're going to get the coefficient. We will be using synthetic. 1, 7, 8, negative 28, negative 48. Okay, first we bring down, we have 1 times 1, we have 1. We add, we have 8. 8 times 1 is 8. We add, we have 16. 16 times 1 is 16. Negative 28 plus 16 is negative 12. We multiply, we have negative 12. And then we add, we have negative 60. So we have a remainder which is 60. That means that 1 is not a root of this polynomial. Okay, let's work on with negative 1. Let's check if negative 1 is a root or not. 1, 7, 8, negative 28, negative 48. So this is a trial and error. So we need patience in doing this. So bring down 1. We multiply, we have negative 1. We add, we have positive 6. We multiply, we have negative 6. We add, we have positive 2. We multiply, we have negative 2. We add, we have negative 30. Negative 30 times negative 1 is positive 30. And then, we add, we have negative 18. Again, we have a remainder, which is negative 18. Okay? So, we then again want to try for positive 2. Let's try if positive 2 is a root. Okay, let's now try if positive 2 is a root. So again, we bring down 1 times 2 is 2. We add, we have 9. 9 times 2 is 18. We add, we have 26 times 2. We have 52. Okay, 52, negative 28 plus 52 we have positive 24. 24 times 2 is 48. So here, the remainder is 0. So it means that one of the roots is positive 2. Okay, now, let's work on, let's find other roots. So, since we have 2, let's now try negative 2. So, but this time, we will be using now the depressed equation. 1, 9, 26, 24. This is now the coefficient of the depressed equation. Okay? And then we bring down. 1 times negative 2 is negative 2. We add, we have 7. 7 times negative 2 is negative 14. Okay? We add, we have positive 12. 12 times negative 12, 12 times negative 2 is negative 24. We add, we have 0. Again, we have 0 for the remainder. So it means that negative 2 is one of the roots. Now, we will be using now 1, 7, negative 12 for our depressed equation. So this is our coefficient, the last three coefficients that we got from the synthetic division, and we translate it into quadratic. This is our depressed equation. X squared plus 7x plus 12 equals 0. Remember the one that we reviewed, which is on factoring quadratic equations. So we will be applying that on this. So we factor the first term, which is x times x. And then factors of 12 that will give you sum of 7. So those are 4 and 3. So we have positive, positive. 4 times 3 is 12. 4 plus 3 is 7. And then we're going to equate both factors by 0. X plus 3 equals 0. And then we solve for x. So we have negative 4. On the other side, we have x equals negative 3. So these are the roots, negative 4, negative 3. So the roots are 2, negative 2, negative 4, negative 3. That's it. Alright, let us deal with this next example. Find the roots of the polynomial equation x to the fourth plus x cubed minus 11x squared minus 9x plus 18. So let us determine first the possible roots. Okay, so luckily we have a leading coefficient which is 1, so we just need to focus on the factors of our constant term which is 18. So those are positive negative 1, positive negative 2, positive negative 3, positive negative 6, positive negative 9, positive negative 18. So 1 times 18 is 18, 2 times 9 is 18, 3 times 6 is 18. Okay, so those are the possible roots. Now we can apply now the factor theorem. So let's begin with positive 1 if it's a root. Then we get the coefficients again. We have 1, 1, negative 11, negative 9, 18. So we have to get a remainder which is 0. So 1 times 1 is 1. We add, we have 2. 2 times 1 is 2. We add negative 9. Negative 9 times 1 is negative 9. We add, we have negative 18. Negative 18 times 1 is negative 18. So, it means that one of the roots is positive 1. Okay, now, we can proceed in identity or using negative 1. So, this is now the depressed equation. So, we get the coefficients 1, 2, negative 9, negative 18. Let us try if negative 1 is a factor. So, we have 1 times negative 1. 2, we have 1. 1 times negative 1 is negative 1. We add, we have negative 10. So, we have positive 10. Oh, we have a remainder. We have a remainder which is negative 8. So, it means that negative 1 is not a root of this polynomial. So, let's try having positive 2. Let's try positive 2. Now, let's try if positive 2 is a factor. So, we bring down 1. We multiply, we have 2. We have 4. 4 times 2 is 8. We have negative 1. Negative 1 times 2 is negative 2. We add, we have negative 20. So, again, positive 2 is not a root. Let's try having negative 2. So, we will again use this one. 1, 2, negative 9, negative 18. So, we bring down. 1 times negative 2 is negative 2. We have 0. 0 times negative 2 is 0. We add, we have negative 9. Negative 9 times negative 2 is positive 18. So, here we go. The remainder is 0. So, it means that negative 2 is one of the roots. Let's now work on with the 1, 0, negative 9, depressed equation. So let us translate this into quadratic form. So we have 0x. So you don't need to place 0x anymore. You just need to bring down negative 9 equals 0. Okay, remember the technique that I taught you, that if b is 0, we just simply, we have to transfer this one on the right side. We have positive 9. And then we get the square of both sides. Square root, cancel. X is equal to, since 9 is a perfect square, we have positive, negative 3. So we have the following roots. 3, negative 3. So these are the roots. So it means that 1, negative 2, 3, negative 3 are roots of the polynomial equation x to the 4th plus x cubed minus 11x squared plus 9x plus 18 equals 0. So that's it for our rational root theorem.